So in this lesson, what we're going to look at is we're going to explore some properties about kites and trapezoids. So we are not going to do the warm-up here. If you completed the warm-up, you would have created a shape that would turn into a kite. So to begin, let's review what a kite is. A kite is a quadrilateral with exactly two distinct pairs of congruent consecutive sides. And then if you want a easy way to create a kite, if you created two different isosceles triangles that shared a common base and then removed that base, you would create a kite. So if you look at this picture of a kite over here, if I drew in the base of the two isosceles triangles, you'd see you have an isosceles triangle on the left and an isosceles triangle on the right. When you remove that base, you end up with a kite. Now, there are four angles in a kite. There are two vertex angles and two non-vertex angles. The vertex angles are the angles that are between the pair of congruent sides. So you see right here, your vertex angle is here and here. Those are the angles that are between the congruent sides. This side is congruent to this side, so the vertex angle is the one that that's between those two sides. So then you have your non-vertex angles. Those are the other two angles. Those are the angles that are between the non-congruent sides. So what we're going to do is we're going to explore some different properties of kites first. We're going to start by looking at some slides on Desmos and making some observations, and then we're going to take those observations and use inductive reasoning to come up with conjectures. So the first thing that we're going to look at is we're going to look at a conjecture and see if we can make a conjecture about the angles of a kite. So I have a kite created here, and what I'm going to do is I'm going to change the kite around. I'm going to adjust some settings here, and I want you to tell me, or I want you to think about what you notice in terms of the opposite sides, the non-vertex angles, and the vertex angles. So again, remember your vertex angles here would be the ones that are 105 and 31. The non-vertex angles would be the ones that are 112 and 112. So do you notice anything about any of the angles as I move them to create different kites? Do you notice anything that stays the same? Do you notice anything that changes? What are some similarities that you notice? And what you should notice is that your opposite sides are congruent. So 8.8, 8.8. Your non-vertex angles are congruent every time. If you look at that, 128, 128, 101, 101, 141, 141. And your non-vertex angles are not congruent. So you have 43 and 29, 60 and 52. No matter how you adjust the kite to create a new one, your vertex angles are not congruent, your non-vertex angles are congruent. So if we were going to jot down our observations, we notice that our opposite sides are congruent. We notice that our non-vertex angles are congruent. And we notice that our vertex angles are not congruent. So if we were going to make a conjecture about this, about the angles of a kite, what conjecture could we make? We can't really say anything about the vertex angles because they change. They're not congruent. There's no pattern that we can really see occurring when we move those around. So the only conjecture that we could make is that the non-vertex angles I guess I don't need to write the word angles. The non-vertex angles of a kite are congruent. So that's our first conjecture. So now we're going to take a look at a second conjecture. We're going to see if we can make a conjecture about the diagonals of the kites. So let's jump back over to Desmos, and then let's come to our next slide. And so what I want you to pay attention to as I adjust this is, how do the diagonals intersect? And also the angles that the diagonals make with the vertices of the shape. So I want you to see if you can figure out two things. There are two relationships that we're looking for here. What do you notice about the intersection of the diagonals of the kite? Anytime that I adjust a kite, we get something where we see that this 90-degree angle at the point of intersection never changes. So think about what you could say about that. If we always have a 90-degree angle where they intersect, what could we say about the diagonals in their intersection? And then also take a look at, what do you notice about the angles that are created by the diagonal that intersects the vertex angle? You have 16, 16, 34, and 34. If you look at this, we create this one, we have 49 and 49, we have 21 and 21. What do you notice about those angles? So if we jump back over here to our notes, how do the diagonals intersect? What you should have noticed is that the diagonals intersect at 90 degrees. If two lines intersect at 90 degrees, what's that mean? That means that they are perpendicular. And if you looked at the diagonals, or the angles the diagonals make with the vertices of the shape, you notice that it appears that the diagonal that is intersecting the vertex angles creates two congruent angles. So what does that mean? What does that tell us? That if we have a line that intersects an angle and creates two congruent angles, that means that the diagonal bisects the vertex angles. Okay, and so if we look at that, let's again go back here and check. Do we notice anything about the angles that are non-vertex? It doesn't appear that it bisects the non-vertex angles. Okay, so if we come back over here and we try to make a conjecture, let's first take a look at the kite diagonals conjecture. Okay, so that means that we're going to take a look at this, the second one. My fault. That means we're going to take a look at the first one right here. So the diagonals of a kite are, what can we say? They intersect at 90 degrees, which means they are perpendicular. So the diagonals of a kite are always going to be perpendicular. And if we take a look at the second observation we made, we notice that the angles that the diagonals make with the vertices of the shape, the diagonal bisects the vertex angles. It doesn't do anything to the non-vertex angles. There is nothing special there. So what we can say is the vertex angles of a kite are bisected by a diagonal. Okay, and again, that means that we now know that if we have a kite, that the vertex angles are going to be, if you draw the diagonal, that you bisect the two vertex angles. Now, let's take a look at our next conjecture that we have. If we jump to the next slide here, I want you to take a look at what we notice about the measurements of the diagonals. So if you look at these, you should notice that as we create these kites, that as we create these kites, what do you notice about the measures of the diagonal? And what you should notice is that the diagonal from the vertex angle is a perpendicular bisector. So they're perpendicular, and the diagonal that connects the vertex angles is actually bisecting the diagonal that connects the non-vertex angles. So if we jump back over here, how do the diagonals intersect each other? The diagonal from the vertex angle appears to bisect the other diagonal. And what that leads us to is this conjecture, the diagonal bisector conjecture. And what that says is the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. And so that allows us to know that relationship between the lengths of the diagonal between the non-vertex angles. So those are the 4 conjectures that we have for kites. We have a conjecture about the angles. We have a conjecture about how the diagonals intersect each other, a conjecture about how the diagonal intersects the vertex angles, and finally the 4th one that we have is how the diagonals, one diagonal bisects the other diagonal. So what we're going to do is we're now going to flip over to some properties about trapezoids, and we're going to do sort of the same thing. We're going to look up, we're going to look at make some observations and come up with a few conjectures. So before we get started, remember a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. The parallel sides are called your bases. So in this case, we have our base, because those are the parallel sides. A pair of angles that share a base as a common side are called base angles. So you have base angle here and here, and then base angles here and here because they are sharing the same base. Now, let's go ahead. We're going to first talk about what we notice about consecutive angles. Okay, and so consecutive angles are going to look like this. They're angles that share a same side. So here and here. Okay. So let's jump over to Desmos and take a look at some trapezoids. All right. So I want you to pay attention to what you notice about consecutive angles. So if we take a look at this, what do you notice about any of these consecutive angles? As I adjust these measurements of these angles here, I want you to pay attention to specifically angles B and C, angles A and D. What do you notice about them? If I have 91 and 89, 91 plus 89 is 180. 126 plus 54 is 180. If I adjust this over here, 87 plus 93 is 180. 91 plus 89 is 180. 130 plus 50 is 180. 87 plus 93 is 180. So what do you notice about these consecutive angles? Okay, so what you should notice is that the consecutive angles are supplementary, meaning the sum of the 2 angles is 180 degrees. So what we can come up with for our first conjecture here is that the trapezoids, if you look at their consecutive angles, the consecutive angles between the bases of a trapezoid are supplementary. Okay, and again, that's going to be the bases between the angles between the 2 bases. So here and here, here and here. Okay, it's not going to be here and here. It's just between the 2 bases. Okay, now jumping over to another type of trapezoid, we're going to talk about a few properties for isosceles trapezoids. Isosceles trapezoids are a trapezoid where there are 2 non-parallel sides that are the same length. Okay, so you have your 2 bases that are parallel, and then you have 2 other sides that are congruent. So what we're going to do is we're going to take a look at some isosceles triangles. We'll come up with 2 conjectures. So jumping over to Desmos, let's take a look at this isosceles triangle. or isosceles trapezoid. So we have an isosceles trapezoid here. So what I want you to take a look at when we adjust these is, what do you notice about the base angles? So again, the base angles would be this one up here, this one up here. So the two that are 119 and the two that are 61 right now. So what do you notice as we change these? What do you notice about the base angles? 121, 121, 59 and 59. 100 and 100, 80 and 80. So at this point, you should probably be able to make a conjecture. You notice that these base angles appear to be congruent. Okay. Now, again, this is only for isosceles trapezoids. So the base angles of, again, an isosceles trapezoid are congruent. Finally, we're going to take a look at what we notice about the diagonals of an isosceles trapezoid. Again, this is about an isosceles trapezoid, not just a normal trapezoid. So if you take a look at this, I want you to pay attention to what you notice about the lengths of the diagonals of the trapezoids. So if you look at this, what do you notice about these two trapezoids? Okay, so if you take a look at that, you should notice that there are some congruencies, correct? So what we have here is that the diagonals, if you look at this, we have 6 and 2.42, 2.42 and 6. If you add those together, you would get 8.42. 3.69, 3.69, 4.73, 4.73. If you added 4.73 and 6.9 for each of those diagonals, you would get the same number. So what you should notice here is that the diagonals, or the length of the diagonals of the trapezoid, are congruent. Okay, they're the same length. And again, this is for isosceles trapezoids. The diagonals of an isosceles trapezoid are congruent. This is not for all trapezoids. Now, our final thing that we're going to look at in these notes is we're going to do an example, but first we're going to create a flowchart proof about proving the isosceles trapezoid diagonals conjecture, proving that the diagonals of an isosceles trapezoid are in fact congruent. So previously in our lessons, you saw that we talked about when we have triangles that are overlapping, we want to pull out what we were trying to prove are congruent and redraw them. So we have triangle TPA and we have triangle RAP. So if we look at this, we want to create a flowchart proof of this that shows that indeed TA and RP, which are the diagonals of this trapezoid, are congruent. So we have two triangles here. So the first thing that we can do is that we would say we know TP is congruent to RA. We know that because that is given to us. We also know that PA is congruent to PA. And we know that because those are the same sides. Now, the next thing that we know is we also know that this is an isosceles triangle or trapezoid. So we're going to say trapezoid TRAP is isosceles. And why can we say that? Because that's given to us. Now, this leads to us being able to say that angle A and angle P are congruent. Angle A is congruent to angle P. Why can we say that? Because we know that base angles of isosceles trapezoids are congruent. Okay. Now that means that angle P is congruent to angle A. And I guess probably we should be a little more clear because it's technically that can get a little confusing there if we just say angle P and angle A, since they are listed twice. So we can say angle TPA is congruent to angle RAP. Now that we have that those two angles are congruent, we have a side angle side congruency. So we can now say that these three things lead to us being able to say triangle RAP is congruent to triangle TPA. And that would be side angle side congruency. And finally, what that allows us to do is say that B or RP is congruent to TA, and that is by CPCTC. So that proves that the diagonals of an isosceles trapezoid are in fact congruent. Therefore, we are able to now accept that conjecture as true. So we're going to look at one last example here, and we want to find the measure of each lettered angle. This is the type of problem that will show up on your homework. This is the type of problem that will show up on your quiz, where you have to use what you know about, in this case, a kite, to determine what the measurements of these missing letters are. So if we look at this, let's go about our business and see if we can figure out what these missing letters are. So we have A, B, C, D. And let's start to see if we can figure anything out. So let's think about what we know about kites. First of all, we know that the diagonals bisect each other. We know that the vertex angles are bisected by the diagonal. And we know that the diagonal from the vertex angles bisects the other diagonal. So let's think about what we know. Since the diagonals intersect at a 90-degree angle, that means we also know angle B would be a 90-degree angle based off the linear pair conjecture. And that means we also know that this is 90 degrees. So we know all four of these angles are 90 degrees. Now, we also know that this angle down here is 60 degrees. That would mean that this angle over here would have to be 30 degrees because of the triangle sum conjecture. Well, if this is 30 degrees, that means we know C is 30 degrees because we know that that diagonal bisects the vertex angle. And if we know that's 30 degrees, we also know A is 30 degrees. Scratch that. We don't know that. Jumping the gun. Now, let's look up here at these other A and D. So if we look at the angle A is a base angle of an isosceles triangle. And since that top angle is 90 degrees, that means we know the base angles are going to be congruent. So A is going to be 45 degrees. And that would also mean that angle D would be 45 degrees as well, because same reason, this angle B is 90 degrees. This is an isosceles triangle. That means that the base angles have to be congruent. So 90 divided by 2 is 45 degrees. So that is what you're going to be asked to do a lot of. So go ahead and begin working on the homework. If you have any questions, message me on Remind or on email and I'll get back to you. Please check your answers on Canvas and ask any questions if you don't understand them at the beginning of class.